Hello, I am Guruprasad Upadhya, HOD, Department of Mathematics, Canara Engineering College, Bantwal. This is lecture 6 in module 3 of Calculus and Linear Algebra 18MAT11. So in this lecture, I am going to discuss volume as double integral and center of gravity. Volume is nothing but in the xy plane the area double integral of z in xy plane. That means z is integrated with respect to x and y in the area in xy plane. So it becomes volume. Here z is function of x and y. Examples: a pyramid is bounded by three coordinate planes and the plane x plus 2y plus 3z equal to 6. Compute the volume by double integration. When x and y and z are 0, x equal to 6. That means x varies from 0 to 6. In xy plane, z is 0. Therefore, 2y equal to 6 minus x. That means y is half of 6 minus x. So, y varies from 0 to half of 6 minus x. Now, 3z equal to 6 minus x minus 2y. Therefore, z is 1 by 3 into 6 minus x minus 2y. Now, consider x, y and z axis. For each x from 0 to 6, x varies from 0 to 6. Y varies from 0 to a point on this line. So, this is the line with z coordinate is 0 in this plane. That means x plus 2y is 6. So, this is the line. So, y is half of 6 minus x. Y varies from 0 to half of 6 minus x. That means y varies from 0 to half of 6 minus x. Now, for any xy, z coordinate is on this plane, that is x plus 2y plus 3z equal to 6. Therefore, 3z equal to 6 minus x minus 2y means z is 1 by 3rd of 6 minus x minus 2y. So, this is the plane x plus 2y plus 3z equal to 6. Therefore, the volume of this pyramid is double integral z dx dy. X varies from 0 to 6. For every x, y varies from 0 to half of 6 minus x, z dx dy, or z is 1 by 3rd of 6 minus x minus 2y. 3z is 6 minus x minus 2y. Therefore, z is 1 by 3rd of 6 minus x minus 2y. Now, first integrate with respect to y, because y varies from 0 to half of 6 minus x. For each x from 0 to 6. Integral of 6 minus x minus 2y with respect to y is 6y minus xy minus y square. Integral of y is y square by 2, cancel 2, so y square. And limit of y is from 0 to half 6 minus x. Now, 6y minus xy minus y square, upper limit of y is half 6 minus x. So, here take y common outside. 6 minus x minus y is half of 6 minus x. 6 minus x minus half of 6 minus x is half of 6 minus x. Again, y is half of 6 minus x. Therefore, it becomes 1 by 4th of 6 minus x whole square. I will repeat once again. This y coordinate is half of 6 minus x and here is 6 minus x. Assume that 6 minus x is a minus a by 2, that is a by 2. Here again a by 2, totally a by 4, that means into a square. A by 2 into a by 2 is 1 by 4th of a square, that is 6 minus x whole square. 1 by 4 into 1 by 3 is 1 by 12. integral 0 to 6 minus x whole square dx. Now assume that this is your x square integration with respect to x is x cube by 3 divided by coefficient of x, that is minus 1, and hence this integral is minus 1 by 12 6 minus x whole cube by 3. Limit is from 0 to 6. For the upper limit, 6 minus 6 is 0, upper limit value is 0, and lower limit value of x is 0 means it is 6 cube by 3. So minus minus plus 6 cube by 3, in the denominator one more 12 is there, so it becomes 6 cube by 3 means here 12 into 3 is 36, that means 6 square, so 6 remains. So 0 minus minus 6, therefore it is 6. So volume of the given solid is 6. One more question. Find the volume of tetrahedron bounded by the plane x by a plus y by b plus z by c equal to 1 and the coordinate planes using double integration. Here this plane is in intercept form, x intercept is y, a, y intercept is b and z intercept is c. Therefore, volume is x varies from 0 to a. When y is 0, z is 0, x by a is 1 means x equal to a. Upper limit of x is a, lower limit is 0. X varies from 0 to a. For each x, y varies from 0 to b into 1 minus x by a. Because when z is 0, in xy plane, y coordinate is y by b is 1 minus x by a. Therefore, y is b into 1 minus x by a. For each x and y, z is nothing but z by c is 1 minus x by a minus y by b. Therefore, z is c into 1 minus x by a minus y by b. Now, integrate this first with respect to y. Since 1 minus x by a is constant, its integral is 1 minus x by a into y minus y square by 2b. Limit of y is from 0 to b into 1 minus x by a. Here, by taking y outside, 1 minus x by a into y, that is b into 1 minus x by a minus b into 1 minus x by a whole square by 2b. So it becomes, by taking y common outside, 1 minus x by a minus y by 2b, upper limit of y is b into 1 minus x by a. So it is a, assume that this is 1 minus x by a minus b into 1 minus x by a by 2b means cancel b. So 1 minus x by a by 2. A minus a by 2 is a by 2. That means half of 1 minus x by a into y. Y is b into 1 minus x by a. Therefore, it is b by 2 into 1 minus x by a whole square. After simplification, it becomes b by 2 into 1 minus x by a whole square. So, b into 1 minus x by a into half into 1 minus x by a. Therefore, it is b by 2 into 1 minus x by a whole square. That is integrated with respect to x from 0 to a and multiplied by c. And hence, b into c is bc by 2, take b by 2 outside, so bc by 2, 1 minus x by a whole square dx. So integral of 1 minus x by a whole square is 1 minus x by a whole cube by 3 divided by minus 1 by a. Therefore, it becomes minus abc by 2 into 1 minus x by a whole cube by 3. So 2 into 3 is 6. Upper limit of x is a by a is 1, 1 minus 1 is 0. Therefore, this value is 0 for the upper limit of x, and lower limit of x is 0, 1 minus 0 is 1, 1 power 3 is 1, so minus abc by 6. Therefore, 0 minus abc power abc by 6 is plus abc by 6. Therefore, this is the volume of this tetrahedron bounded by the plane x by a plus y by b plus z by c equal to 1 and the coordinate planes xy plane, yz plane, zx plane, that volume is ABC by 6. For example, calculate the volume of the solid bounded by the planes x equal to 0, y equal to 0, z equal to 0 and x plus y plus z equal to 1. So x vary from 0 to 1 because when y is 0, z is 0, x is 1. X vary from 0 to 1 and when z is 0, y varies from 0 to 1 minus x. Integrate z. Z is 1 minus x minus y. That is the required volume. X varies from 0 to 1. For each x, y varies from 0 to 1 minus x. Integrate z. Z is 1 minus x minus y. Integrate first with respect to y. 1 minus x is constant. Integral of 1 minus x is 1 minus x into y minus y square by 2. Limit of y is 0 to 1 minus x. By taking y outside here, 1 minus x minus y by 2. Y is 1 minus x by 2. 1 minus x minus 1 minus x by 2 is nothing but 1 minus x by 2 into y, that is 1 minus x, and hence it is 1 minus x whole square by 2. Integral of this is 1 minus x whole cube by 3 divided by minus 1 into 2, that is minus 2. And hence it is minus half into 1 minus x power 3. Limit of x is from 0 to 1. Upper limit is 1 means here by 3, 2 into 3 is 6 denominator. 1 minus x whole cube by 3, 3 to the 6 divided by minus 1. Therefore, minus take outside. Upper limit x is 1. 1 minus 1 is 0. Upper limit value of this is 0 minus plus lower limit of x is 0 means 1 power 3 is 1 by 6. So 0 minus 1 by 6 is 1 by 6. Therefore required volume is 1 by 6. One more example. Find the volume of the ellipsoid x square by a square plus y square by b square plus z square by c square equal to 1. Now, to find the volume of this ellipsoid, consider the volume in the first octant. The required volume is 8 times of the volume in the first octant. In the first octant means x varies from 0 to a because x square equal to a square means x equal to a. In the first octant, x varies from 0 to a. For each x, y varies from 0 to b into root 1 minus x square by a square. Integrate z. Z is nothing but 1 minus c into root 1 minus x square by a square minus y square by b square. Therefore, volume is 8 into, see this integral x varies from 0 to a, y varies from 0 to b into root 1 minus x square by a square. Integrate z. Z square is 1 minus x square by a square minus y square by b square into c square. Therefore, z is c into root 1 minus x square a square minus y square by b square. By taking c outside, so 8 times of c, that means this is volume in the first octant multiplied by 8, that is volume of the ellipsoid. Now, 1 minus x square by a square is constant when you are integrating with respect to y. Assume that 1 minus x square by a square is capital A whole square. By taking b square outside, 1 minus x square by a square, see 1 by b square is taken outside means multiplied by b, so it is b square into 1 minus x square by a square minus y square. So 1 by b square, when it comes outside the square root sign, it becomes 1 by b. Limit is from 0 to b into root 1 minus x square by a square. Assume that this is capital A. Now this integral is nothing but 1 by b into integral 0 to capital A square root of a square minus y square. By substitution method, assume that y is a sin theta. This becomes a square cos square theta d theta. Integrates from 0 to pi by 2. Therefore, take a square, capital A square outside, a square by b, cos square theta integral from 0 to pi by 2 is pi by 4. So, pi by 4, here 1 by b into a square, this a square. But a square is nothing but b square into 1 minus x square by a square. So, this is a square, b square into 1 minus x square by a square divided by b. Therefore, b into 1 minus x square by a square into pi by 4. So, this is the integral, first integral here, and this is integrated with respect to x from 0 to a, and hence it becomes 8c into pi by 4 b means 8 by 4 is 2 bc pi into integral 0 to a 1 minus x square by a square dx. Integral of 1 is x, integral of x square is x cube by 3, and hence it is x minus x cube by 3a square. Limit of x is from 0 to a. Upper limit of x is a means a minus a cube by 3a square is a by 3. A minus a by 3 is 2a by 3. 2 into 2, 4, a, b, c by 3 into pi. Therefore, 4 pi abc by 3. So, this is the required volume of this ellipsoid. Now, we will discuss the center of gravity. Center of gravity formula in Cartesian form is x bar is, so center of gravity of a surface S is given by x bar is double integral x rho into dx dy. Rho is density divided by double integral rho dx dy, and y bar is double integral y rho dx dy divided by double integral rho dx dy. Here, if rho is constant, you can cancel rho here. Otherwise, substitute the function of rho and then evaluate the integrals, find x bar and y bar, that is center of gravity. And this integration is over the surface S, given surface S. To remember this formula in polar form, put x is r cos theta, dx dy is r dr d theta. R into r square cos theta into rho into dr d theta. In the denominator, double integral rho r dr d theta. Here y is r sin theta, therefore r square sin theta rho dr d theta double integral divided by double integral of rho into r dr d theta, that is y bar. So, rho is constant, cancel rho, x dx dy, here dx dy, double integral over the surface S. That is how we can calculate the center of gravity x bar y bar in polar form. So, it is very easy to remember the formula in polar form. Put x is r cos theta, dx dy is r dr d theta, and y is r sin theta, dx dy is r dr d theta. So, you will get x bar y bar if the area is given in polar form. Find by double integration the center of gravity of the area of the cardioid r equal to a into 1 plus cos theta if density is constant. Now, if density rho is constant, you can cancel rho from numerator and denominator, therefore, ignore rho in the formula. And not only that, this cardioid is symmetric about initial line, therefore, center of gravity lies on the initial line only. So, in the initial line y coordinate is 0, that means y bar is 0. So in the center, y coordinate of the center of gravity is 0. So only find x bar. So y bar is 0 because density is constant and the cardioid is symmetric about initial line, and hence y bar is 0. To find x bar, so x bar formula is in polar form double integral r square rho cos theta dr d theta divided by double integral r dr d theta into rho. Cancel rho because rho is constant. Therefore, evaluate first double integral r square cos theta dr d theta in this area. So here area of cardioid means that theta varies from minus pi to pi. For each theta, r varies from 0 to a point on the cardioid, that is a into 1 plus cos theta. Integral of r square with respect to r is r cube by 3, cos theta is constant, and hence 1 by 3 is taken outside, a cube is taken outside, 1 plus cos theta whole cube. That means r cube by 3 is there, 3 is here, r cube, a cube, 1 plus cos theta whole cube into this cos theta. Integrate this from minus pi to pi. Now, first you expand this, 1 plus cos theta whole cube is 1 plus 3 into 1 square into cos theta plus 3 into 1 plus cos square theta, 1 into cos square theta. So 3 cos square theta plus cos cube theta. 1 plus x whole cube is 1 plus 3x plus 3x square plus x cube. Multiply this with cos theta. Cos theta into 1 is cos theta plus 3 cos square theta plus 3 cos cube theta plus cos power 4 theta. So integrate this from minus pi to pi, and you know that cos theta is even function, and hence minus pi to pi is nothing but 2 times of 0 to pi. But cos of pi minus theta, cos of pi minus theta is minus cos theta by the second law of net integral. So the integration from minus pi to pi is 0 to pi is 0 for odd power of cos, and for even power of cos it is 2 times. Therefore 2 into 2, 4 times. The formula is like this: minus pi to pi cos power n theta d theta is 0 if n is odd, and 4 times of 0 to pi by 2 cos power n theta d theta if n is even. Why? Because minus pi to pi becomes 2 times of 0 to pi because cos is even. 2 times of 0 to pi becomes 4 times of 0 to pi by 2 for n is even, because cos pi minus theta is minus cos theta. If n is even, it becomes plus, and hence it is 2 times of 0 to pi by 2. So one more 2 is there. So 4 times of 0 to pi by 2 cos power n theta d theta if n is even, and 0 if n is odd. Therefore cos theta integral from minus pi to pi is 0, and cos cube theta integral minus pi to pi is 0. Therefore you are going to integrate only 3 cos square theta and cos power 4 theta, that is 4 times of 0 to pi by 2, 3 cos square theta plus cos power 4 theta d theta. Here 4 a cube by 3, 4 times of a cube by 3, 4 a cube by 3, take outside. Cos square theta means 2, 1 pi by 2, so pi by 4 into 3, so 3 pi by 4. Cos power 4 theta means 4, 3, 2, 1, that means 4 by 8 into pi by 2, that is 3 by 4 into 2, 8 into pi by 2, therefore 3 pi by 16. Multiply here numerator and denominator by 4, or you take 4 common outside, any method. So 4 into 3, 12 plus 3, 15 pi by 16, and cancel 3. So 5 pi a cube and 16 means cancel 4. So 5 a cube by 4 pi. So that is x bar, and we know that y bar is 0, and hence the denominator of the x bar is double integral r dr d theta So integration with respect to theta minus pi to pi, for every theta from minus pi to pi, r varies from 0 to a into 1 plus cos theta. Therefore, integral of r is r square by 2, take 2 outside, upper limit of r is a into 1 plus cos theta, its square is a square into 1 plus cos theta whole square. A square by 2 is taken outside. By the previous case, here 1 plus cos theta whole square is 1 plus 2 cos theta plus cos square theta. For odd, this integral is 0. Therefore, you consider only 1 plus cos square theta, and minus pi to pi becomes 4 times of 0 to pi by 2. 4 by 2 is 2. So, 2a square integral 0 to pi by 2 1 plus cos square theta d theta. Now, integration of 1 is theta and cos square theta integration is pi by 4 from 0 to pi by 2. Therefore, pi by 2 plus pi by 4, that is 3 pi by 4 cancel 2. So, 3a square by 2 pi. Numerator is 5a cube by 4 pi, cancel pi and a square. So, the remaining term is 5a by 4 divided by 3 by 2, or 5a by 4 into 2 by 3, and hence x bar is 5a by 6. Y bar is 0. Therefore, center of gravity is 5a by 6 comma 0. So, divide these two. So, this integral here rho is constant, therefore, take rho outside from both sides. So, cancel rho. So, this integral is 5a cube by 4 pi and denominator is 3a square by 2 pi, cancel pi and cancel a square. So, a remains 5 by 4 into 2 by 3, cancel 2, denominator 2 into 3 is 6, 5a by 6, that is x bar. So, how we can find the center of gravity of the cardioid if the density is constant? One more example, find by double integration the center of gravity of the area of the first quadrant of the curve x by a power 3 by 2 plus y by b power 3 by 2 equal to 1, and density is being rho equal to kxy, where k is constant. Therefore, in x bar y bar, the rho is kxy, take k outside from numerator and denominator of x bar, you can cancel k, and hence x bar is double integral x rho dx dy, denominator is double integral rho x dx dy. Here rho is kxy, take k outside, x square y, denominator is xy. So, double integral x square y dy dx, denominator xy dy dx. Limit is the first quadrant of the curve means x varies from 0 to a, because y is 0. When y is 0, x by a is 1, x equal to a. Therefore, x varies from 0 to a. For every x, y varies from 0 to find the y value, 1 minus x by a power 2 by 3 whole power 3 by 2, that is y by b, and hence y equal to b into 1 minus x by a power 2 by 3 whole power 3 by 2. So, this is the limit. Here also the same limit, because you are integrating in the area of the given curve in first quadrant. So, limits are same, but the function in the numerator is x into xy into k, that is x square y into k, take k outside, denominator xy into k, take k outside, cancel k. So, this is your required integration. Now, how to integrate this? Here, so you need some idea. By the substitution method, Integral of y with respect to y is y square by 2. Therefore, x square into y square by 2. Denominator also. Integral of y is y square by 2 into x. Cancel 2 here in the numerator and denominator. Now, the remaining term in the numerator is x square into y square. Upper limit of y is b into 1 minus x by a power 2 by 3 whole power 3 by 2. X square into b square, because y square means b square, 1 minus x by a power 2 by 3 whole power 3 by 2 square means cancel 2, so whole cube. Denominator is also same, but x into b square 1 minus x by a power 2 by 3 whole power 3. Now, how to integrate this with respect to x? Suppose x is a sin cube theta. So, assume that x is a sin cube t. Cancel a. It becomes sin cube t. Power 2 by 3 is sin square. 1 minus sin square t is cos square t. Cos square t power 3 is cos power 6t. If x is a sin cube t, dx is a into 3 sin square t into derivative of sin t is cos t into dt. Dx by dt is 3a sin square t cos t. And t varies from 0 to pi by 2, because when x is a, sin cube t is a by a, that is 1, and hence sin t is 1 means t is pi by 2. T varies from 0 to pi by 2. X square, a square sin power 6t, a square sin power 6t into b square, and this term, that is 1 minus sin square whole power 3. 1 minus sin square is cos square t, power 3 is cos power 6t into 3a sin square t cos t dt, that is dx in the numerator. And hence numerator becomes a square into this a, so 3a cube into this b square, and here from x square it is sin cube square is sin power 6 into this sin square, so sin power 8t, and this is cos power 6, and here on cos, therefore cos power 70 dt. So this is the required answer. Okay, integral. In the denominator, x is a sin cube t, and this one is cos power 6t. Dx is 3a sin square t cos t dt. Therefore, denominator is sin power 5t, because here sin square and sin cube, totally sin power 5t. 3a square b square sin power 5t cos power 70 dt. Using the reduction formula, you are able to integrate this. 3a square b square is cancelled, only a remains in the numerator. And then sum of these two is 15, here 12. Denominator you start with 15, numerator is 7, 5, 3, 1, here 6, 4, 2, and one of them is odd, no pi by 2. Here denominator 12 and 10 and reduce 2 to 2. Here 5 minus 1 is 4, 4, 2 and so on, 6, 4, 2 and so on. Therefore, the first term is a, constant term is a, and then denominator start with 15, 15, 13, 11, 2 and so on, 11, 9 and so on. Here 6, 4, 2 and 9, 6, 4, 2 and one more term is 8 something, that is 7 something, that is cancelled. 7, 5, 3, 1, 7, 5, 3, 1 is cancelled. Denominator also here 12, 8, 10, 8 and 6, the remaining term cancels from the numerator, and substitute these in calculator, you will get 128 by 429a. This is x bar. Similarly, we can find y bar. Y bar is double integral y rho dx dy divided by double integral rho dx dy. By cancelling k, the constant k, and limit is same, y into xy, that is y xy square. denominator xy. Integral of y square is y cube by 3. Apply the limit carefully. Now, y cube by 3, upper limit is this, b, y cube, b cube, and this x, so 3 is in the denominator. Here, y square by 2, that 2 goes to numerator, so 2 by 3 here. Y cube, that means this is your y cube. So 3 by 2 whole cube is 9 by 2. Here y cube, y square by 2, square of this, therefore power is 3. The same substitution as in the previous case, so it becomes 2 by 3, 3a square b cube, denominator 3a square b square, here sin power 5t cos power 10t dt and sin power 5t cos power 7t dt. By applying the rule, here 3a square b square, 3a square b square cancels, 1b remains, 2 by 3b into 5 plus 10 is 15, 15, 13 and so on. Numerator 5 minus 1 is 4, 4, 2, 9 and something, 9, 7, those terms cancel from the denominator also. Here 5 plus 7 is 12, 12, 10, 8, 6 and so on. Numerator is 5 minus 1 is 4, 4, 2, 7 minus 1 is 6, 6, 4, 2, that cancels from the denominator, and substitute this in calculator and b take outside 128 by 429b. So this is y bar, and hence the center of gravity is x bar is 128 by 429a and y bar is 128 by 429b. So this is how we can find the center of gravity by double integration. Please remember these formulas, so you are able to solve by the substitution method. So take care while substituting the x value. The logic here is to substitute here x by a to make this 1 minus sin square theta, put x is a sin cube t. When x is a sin cube t, here a cancels, it becomes sin cube, power 2 by 3 means sin square. 1 minus sin square is cos square. So that means you are able to simplify this in terms of this sin and cos. So what is the substitution here? X is a sin cube t. Then you know how to substitute everything. Dx becomes, when x is a sin cube t, dx is 3a sin square t cos t into dt. So that is how we can substitute. Then the limit becomes 0 to pi by 2 by the reduction formula. So very easily you can integrate these terms. Okay. This is how we can find the center of gravity. Okay. Thank you for watching. So in the next lecture, I am going to discuss the beta gamma functions and relations between the beta gamma functions. Thank you for watching.